Greetings, detectives. Mrs. McKay here, slowly moving through case 3. We are now on our 5th clue, learning target clue 3-5, and that says I can identify the nth, so you're going to write nth like that, term of an arithmetic or geometric sequence. So go ahead and write these words in the blanks. I can identify the nth term of an arithmetic or geometric sequence, and that means whatever term I want it to be. So I might have a sequence and I want to know what the 50th term is, or the 100th term, or the 1000th term. I'm going to be able to do that using what I know about explicit and recursive equations. So let's very quickly review a couple things here. We've got a constant difference, and remember, a constant difference is used in arithmetic sequences. It's either plus or minus, right? And it's the same term that's either added or subtracted to get to each subsequent term. We have a constant ratio, which is a multiplying or dividing, or we can say multiplying by a fraction, and that's in geometric sequences. So constant differences are used in arithmetic and constant ratios are used in geometric sequences. We've learned that recursive is when you go back to the previous term and you add something. So we're often saying n-1 when we're thinking about recursive. And explicit gives us a very specific equation that we can then use to predict any term, the nth term or whatever term we want to find out. And then last thing, terms are often listed like this: A1, A sub 1, A sub 2, A sub 3, A sub 4. Sometimes you might see A sub 0, okay, A sub 0. And when that's the case, we'll talk about that. And then you'll often see this, A sub n, which just means the nth term, okay? So A sub n is the same as the nth term, okay? So that's our quick review over some of the things that we've been working on. So now let's do a few problems. What comes next? What comes later? Take a look at this sequence. We've got x, which is going to be our terms, and y, which is going to be our function or our value of each term. And notice that this one has a 0 term where x sub 0 or a sub 0 is this one. So when the term is 0, our value is 5. When the term is 1, when it's the first term, our value is 8. When the term is the second term, the value is 11. When x is 3, y is 14. When x is 4, what is y? So to find the next term, what do we need to do? Well, if I'm looking carefully, I'll see that I am adding 3 to each term. Everyone see that? So I'm going to say 5 to 8 as I add 3. And then 8 to 11, I add 3. And then 11 to 14, I add 3. So to find the next term, I need to add 3, right? I need to add 3. And I need to add it to the previous term. So 3 on to 14 would give me 17, right? So that would be my next term. Add 3. Add 3 to 14, I get 17. Now the next thing I want to do is I want to be able to write a recursive rule for this. I want to be able to write a recursive rule. So this time I'm going to say that my starting term is actually f of 0. My first value is f of 0, and that equals 5. And if you notice, I'm going to say that f of n is equal to f of n minus 1, which is the previous term. So if I wanted to know what this term was down here, what this f of n was, well, I'd have to go to my previous term, and I'd have to take the value of that, and then I would add 3. That's my recursive rule, okay? Now to find the nth term, I have to start with 5. I have to start with 5. And I have to add 3. And how many times do I have to add it? Well, let's see. To get to the first term, I added 3 once. To get to the second term, which was, this is a little confusing with this 0 here, I realize that. But to get to the second term, I had to, or when x was 2, I had to add 3 twice. So in this case, when I have a 0 term, I don't always have a 0 term, but in this case, when I have a 0 term, I just have to add 3 n times. Okay? And so my explicit rule is going to be f of n equals 5 plus 3n. Okay? And is this an arithmetic or a geometric sequence, or neither? Well, it's an arithmetic. It's arithmetic. So we'll write arithmetic here. Now, this one we did with a 0 term just to make it very simple so that we didn't have to do any n minus 1s. But we'll find pretty quickly that normally we don't have a 0 term, and so we're starting with our first term, and we're going to go ahead and do this next one. So let's look at this next one. Let's actually say right down here that this is, if we have n, then f of n would be 5 plus 3n. So whatever number we wanted to choose, let's say we wanted to choose 100 for n, then, so if n is 100, then f of n would be 305. So the 100th term is 305, right? 3 times 100 is 300 plus 5. All right, now let's go ahead and look at this next one. So now we don't have a 0 term this time. We have a first term, and I like those better. So we've got our first term is 5, our second term is 10, our third term is 20, our fourth term is 40, and our fifth term is, what do you think? What do you think? Well, let's first figure it out. What do we have to do? Well, to get from 5 to 10, we multiplied by 2, right? We could have said we added 5, but if we tried to add 5 here, we wouldn't get it. So I think we're going to multiply by 2. So then from 10 to 20, we multiplied by 2. And then from 20 to 40, we multiplied by 2. So to get to the next term, we would have to multiply 40 by 2. So to find the next term, we are going to multiply the previous term by 2, right? Multiply the previous term by 2. Up here, we added 3 to the previous term. Now we're multiplying the previous term by 2. So we're multiplying by 2. We're doubling the previous term. So what would our recursive rule be? Well, our recursive rule would be f of n, or f of 1, sorry. We're going to say f of 1 is equal to 5. And then we are going to say f of n equals the value of the previous term, f of n minus 1, times 2, right? F of n minus 1 times 2. So how do we find the term? Well, up here, when we were finding the term, we had to start with a number, so we're going to start with 5. And then we multiply by a power of 2, because we keep multiplying by 2, right? So we multiply, let's not put an X there. We multiply by 2 to a certain power. So let's see. So for the first term, we didn't multiply by anything. We just started with 5. And then for the second term, we multiplied by 2 to the 1 power. And then for the third term, we multiplied by 2 to the second power. And so notice that each time we are multiplying by the power. So we're going to multiply by 2 to the n minus 1 power. We don't multiply it by 2 to the n power, because if we did, for term 1, we would get 5. We would have ended up with 10. So that doesn't quite work. So we're actually multiplying it by the power of 2. That's 1 less than the n. So if we're going to write this as an explicit rule, then we would say f of n equals, I'm going to start with the 5, and I'm going to multiply it by 2 to the n minus 1 power. 5 times 2 to the n minus 1 power. So is this an arithmetic or a geometric sequence? Well, I think you can tell, because we're multiplying by a constant ratio, that it is geometric. And let's go ahead and try one. We're going to go ahead and write down here that if x is n, then y is 5 times 2 to the n minus 1 power. So let's try it. If n was 100, ooh, let's not do that. That's going to be too hard. I don't want to make it be quite that big. Let's say if n was, let's just say n is 7. We'll say n is 7. And I realize that we didn't actually do this one. This would be 40 times 2 is 80, right? That would be 80. So if n is 7, then we would take 5 and we would multiply it by 2 to the n minus 1. So 7 minus 1 is 6, 2 to the 6th power. So 2 to the 6th power is going to be, let's see, 2 times 2 times 2 times 2, 2, 2, 2, times 2 times 2. Is that 6 of them? 1, 2, 3, 4, 5, 6. So this becomes 4, and we'll make this be 4, and this be 4. So 4 times 4 times 4, which becomes 16 times 4, which is equal to 64. So now we have it's 5 times 64. Now I'm not going to try to do that in my head. Instead, I'm going to pull up my calculator and then I'm going to say 5 times 64 equals 320. So to the nth power, 7, or to the 7th, sorry, when x is 7, the 7th term, y is 320. All right? So that is our next one. Now, let's do one more. Let's do this one. And this time I'm going to use a little bit different notation. I've been using all along f of n. This time I'm going to use a different notation, and I want to show you what I mean. So let's look over here at the know this section. For an arithmetic sequence, we can always say that for an explicit function, we would say f of n equals the first term plus the constant difference times n minus 1, whatever n is minus 1. All right, we can always do that. But you might sometimes see it not written as a function, but written as this with the terms of a. So instead, you might see it like this: a of n equals a sub 1. So a sub n, meaning the nth term, is equal to a sub 1, the first term, plus the constant difference times n minus 1. So that's just another way to write it. You just need to be able to see it differently. And then for a recursive, it would look like this. We would always say what the first term is, right? So we would fill in that blank, whatever the first term is, and then we would say f of n equals the function of n minus 1, which is the previous term, plus d. And then another way to do that, if we didn't want to use this function notation, you might see a of 1. You would see a of 1 equals, and it would tell you what a of 1 or a sub 1 is. It might tell you what a sub 3 is. It might tell you what a sub 0 is, but it's always going to tell you at least what one of the terms is. Often it's the first term. And then you would see a sub n equals a sub n minus 1, which just means the previous term, okay, plus d. So they both mean the same thing. One is written as a function, f of n. The other one is written with this this notation of the a sub, which is the helps us to know what how to identify the terms. All right. Now let's look at geometric. So that was arithmetic. So geometric is going to be the same way. An explicit is going to be f of n equals a sub 1, which is the first term, times r, which is the constant ratio, to the n minus 1 power. All right? Or if we were going to just use a as our terms, we would say a sub n is equal to a sub 1 times r to the n minus 1. So really the same thing, we're just replacing f of n with a sub n, okay? And then the recursive would look like this. F of 1 equals whatever it is, we would decide what it is, and then we would say f of n equals the function of the previous term, f of n minus 1, so the previous term times the constant ratio, all right? That's our recursive. And if we were going to use our notation using the sequence notation of a sub n, we would say a sub 1 is equal to whatever a sub 1 is, the first term is. And then we would say a sub n equals a sub n minus 1, which is the previous term, times r. All right? So we're going to go ahead and use this a sub terms this time. we're going to use the a sub terms instead of the function terms, just so that you can get comfortable with both. So let's look at this one. So we have x is 1, y is 2. X is 2, y is negative 6. X is 3, y is negative 18. Let's see. X is 4, y is negative 54, x is 5, y is 162, x is 6, y is negative 486. So can you see what's happening? How did we get from 2 to negative 6? Well, we could look at it and say, well, we had to add, or we had to actually add a negative 8, right? We would add a negative 8 to get from 2 to negative 6, or we would subtract 8. And then we could say that we're going to subtract 8 from negative 6, but that gives us negative 14, not 18. So I don't think that this is an arithmetic sequence. I think it's something different. So let's see if maybe it's a geometric sequence. 2 times negative 3 gives us negative 6, right? And then let's try negative 6 to 18. Could we multiply that times negative 3? Would negative 3 work for that? So negative 6 times negative 3, oh, that gives me a positive 18. And then 18 times a negative 3 would give me negative 54. And negative 54 times a negative 3 would give me, that's a negative right there, would give me a positive 162. Multiply 162 times negative 3, and that should give me negative 486. So what would I do to find the next term? What would I do? Well, I would multiply the previous term what would I multiply it by? I'd multiply it by negative 3, right? So now let's write our recursive rule. And this time, we're going to use our terminology for a. So I'm going to say that a sub 1 is equal to 2. Everyone see that? A sub 1 is equal to 2. And then I'm going to say a sub n is equal to a sub n minus 1. So that means the previous term, the term prior to a sub n, and I'm going to multiply that by our constant ratio, which is negative 3. So how do I find the nth term? I'm going to start with 2. Start with 2 and multiply by negative 3 to the, let's see if it's to the nth power or to the n minus 1 power. So on the first term, I didn't multiply by anything. I just had 2. That's what I started with. Then on the second term, I multiplied by negative 3 just one time. So the second term, I multiplied by negative 3 to the 1 power. On the third term, I multiplied by negative 3 to the second power. So I'm going to do n minus 1. So negative 3 to the n minus 1 power. Now let me go ahead and write that out. So I'm going to say that a sub n is equal to a sub 1, which is my first term, times the ratio, which happens to be negative 3. I don't need to write r, I write the ratio. Negative 3 to the n minus 1 power. So is this arithmetic or geometric? It's geometric. So let's go ahead and write it down here. We're going to say if we know that our nth term, we want to know our nth term, then we would say a sub n equals, let's see, our first term, which is 2, times our geometric sequence, which is -3, to the n minus 1 power. So over here where I wrote a sub 1, I should have really put in our first term, which is what we're starting with. So I'm going to do that right now. Say that this is 2 times -3 to the n minus 1 power. So let's try it out. Let's try it out. Let's try out the our seventh term. If we said a sub 7, then that would be equal to 2 times -3 to the 7 minus 1, so to the 6th power. So -3 to the 6th power times 2. So let's see, -3 times -3 times -3 times -3 times -3 to 3 times -3. Did I get 6 of them there? 1, 2, 3, 4, 5, 6. So these two make a positive 9. These two make a positive 9. And these two make a positive 9. So let's see, this becomes 81 times 9. 81 times 9 is equal to 9, and 9 times 8 is 729. And then I have to multiply that by 2. So 2 times 729 is going to be, let's see, 18, carry the 1. 2 times 2 is 4, plus 1 is 5. And then 2 times 7 is 14, so 1,458. 1,458. We could check this out recursively as well, and what we should be able to do is we should be able to, since this is the very next term, we should be able to multiply -486 by -3, and we should get a positive 1,458. 3 times 6 is 18. 3 times 8 is 24, plus 1 is 25. Carry the 2. 3 times 4 is 12, plus 2 is 14. So, yep, it works. So, once we understand explicit and recursive rules, it's pretty easy to figure out the next term, and it's even fairly easy to figure out the nth term as long as we understand what the explicit rule is. So you should be able to move on and take care of the Slack Math worksheet. Be sure and write down some key ideas. Don't forget that sometimes you're going to see things written as functions, like this with f of n. Sometimes you're going to see them written with the sequence notation with the letter A representing a term. Both mean the same thing, so don't let that confuse you. And I will see you in class.